Hello guys, in this video we're going to talk about vertical motion. Now vertical motion is when an object is moving upward or it is thrown upward and it returns back to the ground. Every object falls back to the ground due to the force of gravity or due to the gravitational acceleration. And due to the force of gravity, everything is attracted back to the earth. Let's say we have a ball and the ball is thrown vertically upward with a velocity of 10 meters per second. It will rise until it reaches a point where it will never further exceed the point. It will never further go up and it will return back. And at that point is known as the maximum height. Let's say this is the overall height the ball can attain, and that's the ground level. Now, as the ball starts to rise, the velocity will start to decrease. If it's 10 meters per second, as the ball starts to rise, it will go 9 meters per second. It will go 8 meters per second. And it will continue to decrease until it reaches zero velocity at the maximum height, 0 meters per second. So take note that at the maximum height the velocity is equal to 0 meters per second. And then it will return back to the ground in a negative direction. It will increase in a negative direction. It will go negative 1 meters per second, negative 2 meters per second, until it reaches negative 10 meters per second at the ground level. Or you can say that the velocity will continue to decrease. It will go 0 and then it will go negative 1, negative 2, negative 3 until it reaches negative 10 meters per second at the ground level. And for the acceleration is constant, is a constant. It is the gravitational acceleration. It is the gravitational acceleration which has already been calculated, and it's negative 9.8 meters per second squared. And these equations are used to describe vertical motion. These equations. And in my previous video on horizontal motion, you will see that we have a positive sign in the middle. We have positive in the middle, we have positive, positive. But now we have negative. Why? Because we have a negative acceleration. We have a negative acceleration. You will come to understand this as we go on through solving the problems. Now S is the displacement. S is the displacement in meters. V is the final velocity in meters per second. U is the initial velocity in meters per second. Acceleration, or A, is the acceleration in meters per second squared. Now for the acceleration, it is the gravitational acceleration, which is negative 9.8, which has already been calculated, so there's no need to. And time is, T is time in seconds. Now let's try and solve the problem. A ball is thrown vertically upwards from the ground with a velocity of 27 meters per second. So now we know what that is, or what that means. It says a ball is thrown vertically upward. So we know that the ball will rise to a maximum height where it will never further exceed the height, and then it will return back to the ground. And it starts with a velocity of 27 meters per second. So let's say this is the ground level, 27 meters per second. We have now we know that as the ball rises, the velocity will start to decrease, and it will decrease until it reaches 0 meters per second at the maximum height. So at the maximum height, the velocity is equal to 0. The question A is asking, how long will it take to rise to its maximum height? How long? So how long is talking about time. The time it needs for the ball to rise to the maximum height. So the time it takes for the ball to rise until it reaches the maximum height. We're going to use this equation. Since this one involves displacement, which the question is not asking for displacement, and this one also involves displacement, and this one as well. So we will ignore the others and use this equation. V is equal to U minus AT. V is the final velocity, so we have to calculate the time required, or time it took for the ball to reach the maximum height. So we know that at the maximum height, the velocity will be equal to 0 meters per second. So this will be our final velocity. So we say 0 is equal to, the initial velocity is 27 meters per second. It starts with a velocity of 27 meters per second. So we write 27 minus, for the acceleration, we know that it is a constant, which is negative 9.8 meters per second squared. So since we have already used the negative sign here, we can just write 9.8 meters per second, 9.8 multiplied by t. Now bring 27 to the other side, it will be negative 27 is equal to negative 9.8. Divide both sides by negative 9.8. Divide both sides by negative 9.8. This cancel off. T will be equal to, or the time will be 2.7555. If you round it off, the time will be equal to 2.76 seconds. So it took 2.76 seconds for the ball to reach the maximum height. So the answer to question A is time is equal to 2.76 seconds. Now let's look at question B. Question B, it says, how high does the ball rise? Now question B is asking what is height, the total height the ball can attain. So we can answer this question looking at the equations to use. We can use either of these, this or this. They will still give the same answer. So let's use this equation. S is equal to 1/2 U minus V multiplied by T. We are to calculate, or we are to find how high does the ball rise. So S is unknown. S is equal to half. The initial velocity is 27 meters per second. 27 minus the velocity, the final velocity is 0, multiplied by the time. We have already calculated the time, which is 2.76 seconds, or we can use the answers that we haven't rounded off, which is 2.755. And then we can solve for S. 27 minus 0 is 27, so half multiplied by 27 multiplied by 2.755, which is 37.2 meters. So now we know that the height is equal to 27.2 meters. Answer to question B is S is equal to 37.2 meters. Let's look at question C. So question C, it composed of 3 questions. After how many seconds since the projection will the ball have a velocity of 5 meters per second upwards? So it is asking for the time it will take for the ball to reach a velocity of 5 meters per second. So we have 27 meters per second. So as the ball rises, the velocity will start to decrease. So it is asking the time it will take for the ball to reach a velocity of 5 meters per second. So that means it will be somewhere here within this interval. V is equal to U minus AT. Our final velocity now will be 5 meters per second. After how many seconds since the projection will the ball have a velocity of 5 meters per second upward? So now our final velocity will become 5 meters per second, and our initial velocity is 27 meters per second minus the acceleration is, we know it's 9.8 meters per second. It is a constant, multiplied by t is unknown. We are to calculate the time it took for the ball to reach the velocity of 5 meters per second. Now we bring 27 to the left hand side. It will be 5 minus 27, which is equal to negative 9.8 multiplied by t. Now 5 minus 27 is negative 22, is equal to negative 9.8. Divide both sides, multiplied by t. Now divide both sides by negative 9.8. T will be equal to 2.24 seconds. It will be 2.24 seconds. So that's the time it took for the ball to reach a velocity of 5 meters per second. So that's the time within this interval. Now question C2. After how many seconds since the projection will the ball have a velocity of, okay, this one is negative 5 meters per second. There's a typing error here. It's negative 5 meters per second downwards. So negative 5 meters per second. So we know that the velocity will increase in the negative direction when it's coming down, when the ball is coming down. So at 0 meters per second it will go negative 1, negative 2 meters per second, negative 3 meters per second, and somewhere here it will be negative 5 meters per second. It will increase in the negative direction. And the question is asking to calculate the time from here all the way till it reaches 5 meters per second here. So the time within this interval. V is equal to U minus acceleration multiplied by t, where our final velocity will be negative 5 meters now, is equal to the initial velocity is 27 minus the acceleration is 9.8, and the time is unknown. We have to calculate the time from here to here. Now bring 27 to the other side. It will be negative 5 minus 27, which is 32. It will be negative 32, which is equal to negative 9.8 multiplied by t. Divide both sides by negative 9.8 to solve for t, where t will be equal to 3.26 seconds. So that's the time it took for the ball to reach a velocity of negative 5 meters per second. Now the last question is, have risen to half its maximum height. S is equal to 1 on 2 u minus v multiplied by the time. Now half its maximum height, so the time it's asking how many seconds since the projection will the ball have risen to half its maximum height. So we have to calculate the time. T will be unknown, but the maximum height is, we have already calculated, which is 37.2 meters per second. Sorry, 37.2 meters. So S will be 37.2, but this time it says half its maximum height, so we divide by 2, which is equal to half multiplied by the initial velocity is 27 minus the final velocity at the maximum height is 0, then the time is unknown. 37.2 divided by 2 is 18.6. 18.6 is equal to half times 27 minus 0 is 27 times half is 13.5 multiplied by t. Divide both sides by 13.5. 18.6 divided by 13.5 is 1.37 seconds. So 1.37 seconds. So that's the time it took for the ball to rise to half its maximum height. So that will be somewhere here. It is 1.37. So 1.37, if we multiply it by 2, if we multiply 1.37 multiplied by 2, it will give 2.74, which is the time it took to reach the maximum height, where the time it took to reach the maximum height is 2.76, which is close to 2.74, so that is correct.